in this session, we are going to cover PNF operations. So with Pietro, you have included the PNF to OSM, so that OSM is aware of that PNF. Okay, and in this picture, basically, I'm showing them the three, the image that I have shown during this morning in another sessions, and just want to point out and remember some concepts. In this case, we are working with PNF, right? So the PNF means that that we are not going to instantiate anything, but we are going to configure an already existing router. In this case, the BIOS router that we are working with. So in that case, we have to use proxy charms again, because we cannot install anything here inside the PNF. So, and just another thing that I wanted to mention is that if you realized with the same toolset, let's say, with the charms, we can write operators for different use cases, totally different use cases, for PNFs, VNFs, KNFs, and so on. So the good thing is that we can easily add primitives, day-2 operations with charms, and it's like you have, if you know how to write charms, then you can write operations and add primitives to any of your workloads. So another thing that I wanted to mention is that if you want to start writing charms and you don't know where to start, I am reachable in the Slack, or I also answer the OSM Tech mailing list. So if you have any questions or whatever, I can help you out and give you some guidance so you are not totally lost. Yeah, I'm glad to help. Okay, so in this session, we are going to, as I said, do this part. Okay, we are also we will also deploy the things that we did in the previous session with the magma virtual EPC and Untitled. So if you guys haven't been able to execute those primitives well or whatever, I will repeat that part again, so so you can do that too. And yeah, but we will focus on this proxy charm, and I will explain a little bit of the insights of it. Okay, so in this case, we are building a BIOS config charm. That's how we call it. And it's a proxy charm, and it only has one action. The action is to configure remote. That basically will tell the BIOS router to allow the traffic for a specific IP. And this IP is the magma virtual EPC IP. That I will let you know how to how to get that. Okay. So as I did before in the previous session, I will explain the VNF configuration. Basically, this is going to be the VNF configuration part, and here we add the UU charm, same way we did in the last examples. Okay, and then the only initial config primitive that we will implement is the config one, which was needed for the proxy charms, and we tell here the OSM or the SSH username and SSH password to use. These are then the username and password for SSHing the BIOS config. And then the config primitive itself, it consists basically of one action that takes one magma IP as parameter. We have set here the default value, but this doesn't matter. We will be explicitly specifying which IP we want to use. Okay, so now I will move into the charm code, okay, and then we will do all the steps. Just one sec. Okay, so we are in the folder June 2. Okay, so here if we go to the Hackfest Gateway VNFD, okay, we will see the descriptor. I'm going to show it very quickly. So in this descriptor, we basically have this part of the VNF configuration. Is the part that I just show in the presentation with the initial config primitive, the config primitive for configuring the BIOS router, and the name of the charm. Okay, there's no much to see there. And then in the charms folder, we see the BIOS config. Okay, so let's go inside. Okay, it's very similar to what we had before. Okay, basically here we have these requirements that is empty, so we could remove it, but I just leave it there. Also, we have the metadata, which is very similar as what we had before. We had something similar to this, but I just want to say one thing, and is that for the proxy charms, we have one template that we use. If Dominica, if you are in the call, you can send the link to the GitHub repo for that template. And basically, that template will give you all the basic that you need to deploy a proxy charm. And it already includes this relation, okay, that is proxy peer, which basically it handles some details so that the charm can work in HA mode. So you could scale the charm if you want, and multiple units of that charm will be created. And if one fails, then the other will be in charge of executing the actions if the first one has died or whatever. So it's just, and I won't be explaining this part because it's a bit more advanced, and we are not, we haven't the time for it. But if you are curious, you can see the code, and if you have questions, just ask me. Here's my email also if you want to ask me something. Okay, so let's go here. Okay, so here in the config YAML, we see that there are several options to the term. These are not all being used. Only we are setting only the SSH password, username, and hostname. Okay, but anyway, these are these config values this file is already in the template, so you don't have to bother a lot to understand this. If you want, you you can, but it's not very difficult. Also, if you go to vim actions.yaml, here we can see the action that I implemented in this chart, basically to configure the BIOS router. And these other actions here are needed by OSM in the proxy charms. So those are already included in the template. So you don't have to bother. These are like built-in primitives in the proxy charm. Okay, so just that. Okay, if I show the source, I see two things, the charm.py and the proxy cluster. This proxy cluster is an example of a peer relation that basically it's the relation between all the proxy charm units in case we scale the proxy charm. Okay. So just for you to understand a bit better, before in the introduction session, we talked about relations and how one charm can be related to another charm, and this is done with a relation. So this is a case of a peer relation that basically it relates the units, the different units of one same application. Okay, so if you want to see the code, you can see it there, but I'm not going to explain it because I don't have the time for it. And also, it's a code that is already there, it's working, and you will just clone it, use it, and it won't make a much difference for you if I explain it or not. Okay, so here in the charm, this line over here is to include the relation, and this part over here is also for the relation. So I'm going to skip this part, okay? This part too, okay? So basically, we will have something very similar to what we had before. Okay, this is a bit more complex because the proxy charm needs to handle more things. It has to check the credentials that he got from OSM to SSH into the machine, see if if the credentials are okay or not, and so on. Okay, so in the constructor, we have this part that basically is very similar of what we had before. Basically, we have a list of events that we are going to listen. These are the same ones as we had before in the previous example of the inode bit. The config change, install, upgrade, start, those are the same. Then we have the one that we have configured, that is configure remote _action. These are the built-in actions, start, stop, restart, reboot, upgrade, and these are for the SSH proxy actions to generate an SSH key, get public key. So these are already in the template, so you don't have to bother. You have to add here only the ones that you have that you are implementing or adding to the proxy channel. So just then observe all those. Sorry, no, this one is for the relation, to observe when the relation is changing, so I'm going to skip that for the moment. Okay, this is already there in the example. So I'm going to jump now to the action that I'm implementing. Okay. Because all of this is already in place when you deploy, so you don't have to bother with that. Okay, so let me find it. Okay, so it's this one. On configure remote action, and well, there are two things I want to explain before, and is in this case, well, we already said that in a proxy channel you can do whatever you prefer. If you want to configure your workload using SSH and running commands, as well, I didn't show it, but running SSH commands or whatever, you can do it like that. If you want to execute, if you are comfortable with Ansible and you want to do it with a playbook, you can do it. If the workload exposes one REST API, you can call that REST API. It's up to you, the way that you want to handle things. In this case, we had already some Ansible playbook to configure the router, so we used that. And basically, I just want to show that in the uninstall hook, I'm doing libansible.install Ansible support. That is some functions that are provided by some module that I'm using. Okay, this basically installs Ansible in the proxy channel, so in the LXD container, so that it can actually execute the playbook. Okay, we want that on install. Okay, and let's go back here, and I want to show, because I forgot, if you go here to playbooks, okay, in playbooks, we have one that says configure remote. So I'm going to show it. It's just a simple playbook that takes this parameter there, and it sets firewall rule or something like that. And it's just the one, and the playbook installed in oh it's hard, sorry. Basically, it's the playbook that is executed to configure the BIOS router. So let's go back here, and here what we do is if the unit is the leader, well, we could remove this and only execute and just execute the action in whatever in whatever unit, but OSM by default will choose the leader unit to execute the action. Okay. When you scale one charm, there will be multiple units, but only one is the leader. Just for your information. And here, when this is the code that in which we are basically running the action, and what we are doing is we are getting the config with self model config, okay, and this config will have the data from here, from the config.yaml, okay. So yeah, first we are doing that. We are getting the magma IP from the event parameter. Okay, so this action had this parameter, the magma IP. So we are getting that. We are constructing this dictionary. okay? Which basically here what we are doing is we are replacing this string with the IP of the that we are passing here. So this will be replaced in the playbook here, okay? If you see, this is like a template, so it will be replaced there, okay? Then here we get the proxy, and we can remove that line because the proxy is not used, so forget about that, my mistake. And then we are doing livansible.execute playbook, and the parameters that are passed here are the name of the playbook inside the playbooks folder, then the hostname, SSH hostname from the config, SSH username, and SSH password. And then this dictionary that will basically replace this variable in the playbook. It's executed, this playbook, and then it sets the results to the it sets this result that basically shows the output, and the output is the output datum from this command. Okay, basically that's it. I want to also to show something. Okay, so here in this basic repo, I have added this like submodule that you will use in the proxy charms that you write. So basically this shows how to use the SSH proxy, livansible, and so on. So how to include those in the in your charm, okay, with git some module, do the links and add the same links needed, and so on. And it shows here a very basic example. For example, in the SSH proxy, you import it, you can check if it has a key or not. If so, if it doesn't, then create it. This for getting the values of the keys generated, and this is for getting the proxy, and you can verify the credentials with this function, and then if verified, then run like a command through SSH with the .run. And if you are doing Ansible, you should install it with this and execute the playbook with this. Okay, basically this is what I have shown, but you can use this approach, the other, or whatever you want. Okay. So yeah, that was one thing, and I don't know if Dominic shared it or not, but just in case, this is the template we are using for our proxy charm. So basically, if you clone it, you will have all the basics. In this case, the action we have added is touch, to touch a file, basically, but you will have everything already in place. You only have to go here, replace this with your action, and then change this with your handlers of those actions. You only have to do that, and it's quite fast. Also, if you need help or whatever, let me know. So now I will go back to the presentation and the terminal, and we are going to be deploying and onboarding the network service again. Okay, so here you can see my previous deployment. Okay. So what I'm going to do now is I'm going to delete it, and well, this will take a bit of time. So first I will delete the magma virtual PC. It's being deleted. Let's give it some time. Okay, we don't have it anymore. And now also if I do use status -m and the name of the model, oops. Oh, someone has changed. Oh no. Someone has changed the permissions of some binaries or something. I try to fix that a bit later. Now I will delete the network service descriptors. Gian-Pietro, are you there?
Yes.
Someone has changed some permissions and I cannot.
Okay. I will check that. Oh, fix it.
I cannot do a status either. So
Okay, we'll fix it right away. No problem.
okay. Thanks. Okay. In the meantime, I'm going to go here, and we can do some things in the meantime. So if you remember, in the June2 folder, we have the parameters. Okay, this file. So as we have, let's say, registered already virtual PC with this ID and this name, okay, we just have deleted, but it's like registered already in the orchestrator. And we need to do some additional steps to remove it definitely from the orchestrator. So what we will simply do is we will edit the params and add 2 here, for example, instead of 1. Okay. Okay. We have the guilty person here. The 36 tenant has changed the permissions to
Worse than that, it seems that all the machine is under the control of one tenant.
yeah.
For 36, they run the chown in all the machine, all the complete file system. So it's going to be very hard now to recover it.
Yeah,
Let me think what we can do. Angel, we will need your help here. Can you please, I will send you some comments to run.
David, you need to.
Yeah, sorry?
Sudo. You need to put sudo before chown.
Oh, yeah, sorry.
Yeah, but
Then
you're not sudoer. You're not sudoer because, yeah, the sudoer's file is owned by another person.
I think I was.
Yes, it should work. I think it should work.
But it's not working. Because we are not sudoers anymore.
Oh, okay.
So we should at least you do this, Angel.
Okay, so basically what we have to do is to change the params.yaml and with these new IDs, okay, and with these commands right here, we could upload the packages. So it's important, as we have uncommented some lines in the network service descriptor to include the gateway. We need to add first the gateway, the PNF descriptor, and then the VNFD, and then after that the network service descriptor that includes both of them. Then the parameter or the command to instantiate is exactly the same as before, so we just execute that. Well, this is the same as before to see all the network services, the status, and we can switch to the GG model and do UU status to see the progress. In this case, an additional proxy charm should be there, basically because it's the one that we've seen in the gateway. Okay, so these two commands were for registering and attaching, well, registering the inode B to the magma EPC, and this one was for attaching the user emulator. So exactly the same commands as before, but after that, what we were going to do is in OpenStack, we could see the magma EPC, okay, and this IP over there is the IP of the magma, okay, the internal one. So what we have to do is execute the configure remote primitive of our PNF, let's say, and we needed to copy that to here, okay, to the parameters, so that the magma IP is set to that, and that would execute the playbook replacing the IP of the magma to include the rule in the BIOS router. Okay.
Sorry.
Yeah.
I have a question. The SGI is not the interface who goes to internet. I mean, the connection between a EPC and the node B should be another one, right?
Gian Pietro will know more about that. Maybe you are
Yes, what was the question?
Sorry, it's because SGI is normally the interface when you use IPC to connect with internet. The connection between
that's right. Let's show the diagram. Do you have it, David?
I think so. Yeah. This one.
Oh. Yes, it can help. If you have the other one, it shows the networking.
Give me a second, I will show it.
Or I can share now. So yes, this is the S1 interface between both BDUs. So for now, it's a virtual one.
The command that we are going to use is for the S1 interface,
it's for
right?
the SGI. Why the SGI? Because the PNF is allowing the traffic from EPCs, based on the IP address of the magma access gateway, which is here in the SGI. That is why you need to get this IP address and run the primitive against a filter that is running in the PNF so that you have internet access.
Yes, exactly. But the other presentation says that this would be for the UE attach.
This has nothing to do. This has nothing to do with that UD attach. UD attach is running a primitive that runs here to the right, natively inside this machine, and since I attach to the network, so this guy here, the EPC, can allow access to the network, and that's it. That's inside the bucket core and its access. Then we are running a different primitive which is hitting the PNF to allow data plane traffic coming from the VPC towards internet.
Okay. Maybe
primitive.
with the title I misconfused.
Mm-hmm.
Sorry.
Okay. No problem. Okay, David, can you recover the presentation?
Yes. I don't have sharing permissions, but basically I think I finished. Yes. One sec. Okay, so basically with that action that I showed before, that was this one.
I can't see your screen.
Yeah. I'm pasting that. Pasting it in the chat. Basically, that was in my last slide. I was showing that, and basically that action will configure the BIOS router to let traffic from that IP pass through the PNF. And well, basically what I was going to do after that is logging into the user emulator, clicking or opening Firefox, and then we should being able to access the internet, because the user emulator is attached to the inode B. The inode B is registered to the Magma virtual EPC, and also the traffic coming from the Magma virtual EPC to the PNF, yeah, it will be it will pass through that PNF because we have the rule there, and we could access the internet. And then the next step was going to be covered in the next session by Dominic, adding the squid web proxy, so that we were going to do a Kubernetes charm with squid, and then in Firefox add it as a proxy, and we would only see or have access to the URLs that we explicitly specify in the proxy. But maybe we can still, well, we are going, probably we can do that, but it's going to take a bit of time to deploy the other instance. So I don't know if
what time is it? 9, 6,
4 o'clock.
4. Okay, let's take a half an hour break for us to restore everything, and we'll come back with a fresh machine with all the files on it.
I think we can start or continue with the session. Okay, this is working fine. Okay, Gianpietro, I think everything worked successfully, because I'm basically installing the the actions for the Magma virtual EPC are being executed. Ansible is being installed in the BIOS config chart, and now I need this to be finalized, the native chart, but it seems fine. Okay, so should I start giving the instructions, Pietro? Maybe Pietro is not in the call. Dominic, are you there?
Yes, hello. Sorry, I was not.
Oh, so it's no, it doesn't matter. Okay, I just deployed the whole package, the whole network service, and it worked fine for me. So if you let me, Dominic, I will log in into your user to show everyone how to follow. Okay, and also you can have that as the basis for your session later on. Is that okay for you?
That's perfect, David. Thank you very much.
Okay. So you have to log in into your with your user. Okay. And Gian Pietro, correct me if I do something wrong. Okay.
Okay.
And now, first of all, don't forget this because it's very, very important. You have to do this, okay? You have to execute this command. I will paste it here. GoToMeeting is very slow today. Okay, but the number will change depending on the user that you are. Okay, so this number will change. Okay, so now that we have done that, if I do M, I can see that the OSM password, for example, is set, and there are a bunch of things that are in place. Okay.
David, sorry, did your charm work already?
Yes, the native charm works.
Okay.
So yeah, everything's fine.
I will copy him.
Okay, so now you have to wait because the scripts are not copied yet. So let's wait a bit.
I'm starting to copy them. Okay, done.
Done. Okay. If you do ls, you will see hf scripts. Okay, this folder. So just go there. Okay, and you will see a bunch of, well, 3 scripts here. So we will start with the recover packages. Okay, just execute that. Okay, and so everyone knows what's happening. Basically, here we are adding the repo, adding the magma KNF network service, and the repo for the Helm chart, and we are using the June 2 packages that we already had in place. We are pushing those. Okay. Okay. Now, the next step is to do recover infra. Okay, so we execute this. A Vim will be created. Now, also a gates cluster, and I don't know what else. I think the PDU is created there. So basically, that's what's happening. First the Vim, the gates cluster, and then the PDU. Okay, so execute it as I have done, and if you do gates cluster list, OSM gate cluster list, okay, so my cluster is enabled. Okay.
Sorry, David, did you
Yes,
copy the cube YAML to everybody?
The what? Sorry.
The cube YAML is missing some cases. Did
Yeah,
you copy?
Those scripts apparently are not copied to our.
It's a folder named HF scripts. Can you check if you have a folder named HS scripts?
No, I don't have.
I don't have it.
Okay, wait a sec.
I can see the cube YAML.
But in their home scripts, not right. In their home.
I have it in.
I'm copying. I already copied. Just copied the cube YAML. You should have a cube YAML. I'm going to run again the copying of the scripts, but it's rare. Check that you are logged in the right machine, because I already copied them. Everybody. Okay, copying them again. Okay,
Yeah,
everybody should have. No tenant. Which tenant? Put door numbers, please, in there. Make sure you are in the new machine, please. Tenant 2. Okay, let's go to tenant 2. You have cube YAML and you have the HF scripts tenant 2. Anyone else? Tenant 17. Make sure you are in the new machine, please. Tenant 17. You have everything as well. Okay, please log into the new machine. Forget about the old machine. So for 819. Forget about it. New machine is 248.55 is the new one.
I can see a bunch of people that have successfully deployed the Gates cluster.
Great.
55.
Don't forget to source first your file, otherwise it won't work, please. So can we go please again to the procedure?
Yes. So first of all, if you haven't done it, okay, you have to do this. Source, I will put here. Okay, source, and in your home folder you will see OSM _ Hackfest _ your tenant number .sh. So execute that first, and after executing it, go to cd HF scripts. So go there, and first of all you need to recover packages like this. I will comment it.
Packages.
Yeah. Is there any question?
Anirudh, I'm seeing the files in there. Let's check. It's cube YAML home directory. It's not inside the HF scripts. It's in the home directory.
Recover infra.
I'm pasting in Slack. Okay. Easier. You just need to run this script and they will do everything for you.
Okay, I see more cakes cluster in processing state. I think we are better now.
Only recover in packages and recover infra, correct?
Yes, so first the packages, then the infra, and just wait until wait.
Infra and packages it doesn't matter, right? The order, because I put it the other way around in the Slack.
Yeah, it doesn't matter. I did first packages and then infra. We have almost everyone. 2 hours backup processing, but okay, anyone?
Luca, which tenant? HF scripts in the new machine, .55. Tenant 8, okay. I will access tenant 8 at the home folder. We should, yeah, there is, actually a script did everything. So unless a for loop is doing awkward things, it should be in your home folder. Make sure you are at the new machine.
Okay, there are
I pasted the commands on Slack, Joe. They are in Slack. But it's not a matter of copying and pasting. You have to replace at least your tenant name in the first line, please.
There are some tenants that haven't deployed a cluster yet. From tenant 3 to tenant 9, for example. But maybe not everyone is active right now.
From tenant, okay. Yeah, but
Okay,
we got 10.
The ones that have executed the recover infra, everyone got it successfully because all the clusters are there. I think we can continue, right?
Should we deploy the network service?
Yes, so now the next thing is to execute the launch NS. Okay? So we will execute that. Is it okay?
Yeah. Well, maybe they should do it, but be careful. It's only when your cluster is enabled. And I put a note on in Slack because we may.
Yeah, except from tenant 7 that just added the cluster, everyone has deployed it successfully. Everyone that has deployed that has executed the command. So if you see my screen, all of them are enabled.
Okay, I fixed a little bit the script in the Hackfest Slack channel. Well, just to clarify that your case cluster must be in enabled state when you run the case cluster OSM case cluster list command.
Okay, should I continue, Pietro, with
Yes.
launch? Okay, so the next thing is launch NS. Okay. Oops.
There is an issue there. Sorry. Let me fix it.
No.
It was working, but no. Your Hackfest tenant is it's okay. It's populated. Did you source the? Can you run the environment?
Or maybe I log out and log in again. Sorry.
Okay. Yeah.
Okay. Yeah. So
the order of the script, Jairo, is in the Slack channel. You have access to the Slack channel. because otherwise I
Oh,
can paste
sorry.
it here, but
Please,
no?
sorry.
Okay, I will paste it here, but it may not look that good. Let's copy and paste that elsewhere so you can see it properly.
Okay, I just launched my network service here. So this first ID is from the Magma orchestrator. Now there's a sleep of 20 seconds, and then it will deploy the virtual EPC. So now after that launch MX script is executed, if you do OSM NS list, you will see two things deployed. The magma orchestrator, which should be in building, and
why is saying not insensitive?
no, yeah, it was
okay.
Okay, so those two are in building state.
Yeah, we're having heavy load at the machine now because everybody's acting at the same time.
Yeah. Okay, if you switch. Okay, yeah, I think everyone is doing it at the same time. Yeah.
Sorry, David. I'm in the OSM Hackfest 557 user, the same one that you are. But when I try to list the case cluster, it doesn't show me anything.
Wait, are you the same user?
Yes, I'm with OSM Hackfest 57.
Have you done the source? But it has failed deploying the.
Yeah, now we have a load maybe.
Okay, maybe I forgot the source. Sorry.
Okay, I think there are some issues with the arrow.
Yeah, it may be overloading.
I think, I don't know, what do you think, but in this tenant, in mine, I have everything deployed successfully. So maybe we could just clean all the instances and just do it here in mine. Computer, what do you think?
Yeah, sorry?
Yeah, I mean that since I have in my tenant everything deployed, I think we could just execute the primitives here, show it to the audience, and let's give access. Let Dominic access this machine so he can continue his session here.
Okay, yes. Yes, please note that Enrique, Jairo, please note that you should wait until you have the case cluster created. But for having the case cluster list populated, you should run infra, the infra command.
Is it okay with you, Dominic?
Yes. Is the radio set up? Should it have access to the internet right now? The emulator?
No, right now no, because I haven't executed
The primitives.
the primitives yet.
Do you want to execute the primitives, or should I just deploy the case jump and all those actions and that's it?
No, if you let me, I will execute the primitives real quick. If it's a matter of minutes, a couple of minutes, and then you can continue if you want.
Okay, go ahead.
I have a question. In my deployment, NS says NS state broken, but current operation is idle. Is that meaning that something went wrong? Is also
I
The
can
deployment, which tenant, sorry?
NS OSM NS list 36. The tenant.
Okay. 36.
Yes,
Okay, just a second.
the best.
Okay, can you see my screen now?
No.
No.
No?
No.
Oh, yeah, can you please, yeah, so the arrow, since everybody was launching at the same time and the machine is not that big, we got arrow crashed, which is one of the components. It got overwhelmed and crashed, but now it should be better. So please, can you try again? I'm deleting your network services, just in case of tenant 36, okay?
You mean run again the script without deleting anything?
Should be the launch. I already deleted for you since I was there already. So just run the launch command, launch ns, okay?
Okay, okay.
Anybody else having issues?
Yes, me, 37.
37?
Hey, can you see my screen?
Yes, 17.
What kind of issues are you having? Instantiating an idle, okay. If it says broken, let me see what happened. So 52. The arrow was down for a little bit. That's the reason. If you see deploying cannot connect to host arrow, blah, 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 you need to delete both. Please don't launch additional instances because it won't work. Just delete everything. Why? Because if you launch the gateway, for example, and the orchestrator is not there, then, okay, you got the gateway, but when you got the orchestrator, you won't have the primitives run against it. Okay, so delete, if you have a broken network service because of the CPU spike we had, just delete all the network services with ns delete and launch again, okay?
Now your action deleting was correct, but now it's not instantiated, which
was your tenant, 36?
36, yes, and I was expecting to have this empty, but it's not empty. Try
It's
again.
empty now.
Oh, really? Maybe it's taking a little time. Oh, yes, now it's okay. Thanks. I'm gonna be running again.
Okay, perfect.
I'm gonna wait for a few seconds to run the script.
Okay.
To give some time others to conclude.
How do I would like to destroy a container in the swarm. Okay, just a second. I'm going to run something that will give us more CPU.
Okay, Gianpietro,
Yes.
should I continue?
Yes.
The primitives.
Mm-hmm.
Okay, I imagine you can see my screen, right? If you can, then here is the last command that the script has executed, which basically has created the magma gateway or the magma virtual EPC. Okay, so I have that already deployed, and if I do the status in that model, I can see that all my charms are deployed successfully. So now, well, we have wait until it is deployed. Okay, so now basically we have to execute the actions. The first action is this one, and we, okay, okay, so basically I'm copying that and changing this to the name of the network service, which is this one for me, and the Vim account. Sorry, the Vim account is not needed. So basically that's it. We will do that, and this is for the inode D2 register. It's slow. Okay. Reading the status. Doesn't matter, we can not see it there, but we are going to log in into the into magma in the virtual PC, and we are going to check the logs to see if the inode B has been registered properly. So we take the IP by executing OSM DNF list, and the one that has DNF member index magma a gateway, we can use that IP. We SSH with the magma user and password. Okay, execute this. Okay, yes. So, yes. So we have the inode B connected. So now we can go back and execute the next action. Oh, yes. I log out. So now we execute the next action, and we do it with the correct name in the network service ID. Okay. Now we SSH to the machine again, to the magma PC, and wait until the end user is attached. Are you guys following? If I can help with anything, or if you have any questions, just write in the chat or talk.
I was still looking for the EPC to build.
Seeing that there is a lot of activity here at the same time.
Yeah.
That this is a problem that we are facing. Okay, so I will reflavor this machine quickly, and hopefully problems will disappear for us. Give me just a sec or some minutes to fix this.
Okay.
And yesterday and earlier today, obviously the situation was different because people were at different rhythms. Now we are all launching the scripts at the same time. So it's
Yeah.
unusual.
Gian Pietro, I have executed the actions to attach the end user.
Mm-hmm.
Do you want me to execute the action in the PNF?
Oh, yes. So they can get familiar with that.
Okay. So this is what we already did in one of the first sessions. And the thing that we have to do in, okay, just one moment. Okay, I'm in the wrong deck. Sorry.
If you want, I can reflavor it right away. It will take some minutes. Or you want to finish with that first?
If you want, I only need to execute this.
Okay, go ahead.
As you want, as you want.
Go ahead.
Okay, so basically, what we need to do is we need to execute the configure remote and pass here the IP of the magma, right? So, sorry, 1 second. I'm going to go here. Okay. Okay, and if I go here, there, I can see the IP. Okay, so I'm going to copy that, and also I'm going to go to the user emulator, and here in the console, I will be able to see the screen. Okay, OSM 2020 is the password. So now, if I go to Google, there's no internet, basically, because we haven't let the traffic of that Magma virtual EPC pass through the PNF. So basically, with this action, what we are going to do is sorry. What we are going to do is copy this over there. Okay. DNF name, well, this is the DNF member index, and BIOS DNF. Action name is configure remote. And here is the IP of Magma. We are going to put this IP. We put it there, and
Sorry, a question. That magma IP is from the magma AGW, no?
yes, exactly. The SGI IP.
Yes, exactly. AGW IP. Okay.
Oh, perfect.
Percentage not indicated.
Okay, if I do use show action status, I will probably see. Okay, this is pending. That is the configure remote. Okay, so if I do in the 14, it is running now. Okay, I want to watch it. So it's running. It should be finished soon. maybe there are a lot of things going on in the machine. Shouldn't take that long. Yeah, Pietro is taking a bit longer than expected, but I think it's because we are running a bit out of resources. That's right.
Hello? Beierl?
Yes, yes. Can you hear me?
Yes, yes, I disconnected. Not sure why, but is everything working okay?
Yes, I run the primitive in the PNF, but it's stuck at running.
Okay.
I think it's because of the resources, because yeah, this is okay.
The resources. So should I go ahead with the flavoring?
Yeah, you need to restart the machine for that, right?
Yes, the takes
But I think some of us are
minutes.
still very behind. We're still waiting for the magma access gateway to actually instantiate.
We cannot hear very clearly. Oh, sorry, it's completed now.
Okay.
Okay, so just one sec. So now the action is completed. So if I go here, okay, so now the route is inserted into the PNF. And we can see the output of the Ansible playbook and so on. But basically, if I now go here to Google, so now we have access, and yeah, it's we have access since we have executed or added the ruling into the PNF. We can also do, for example, include on the degree. We can do a trace path to the Google DNS server, and we can see here that we are going through the IP of the magma. I think this is
This is the gateway of Etsy. I mean, of this network that we are giving in Etsy. After the BIOS router, which is at 239.7, which is the previous one.
so we have like end-to-end test the whole thing.
Yeah.
And this is I have finished my session, but now I will give some space to Dominic so that he can finish his session.